بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على سيدنا محمد وعلى آله وصحبه أجمعين. Assalamu alaikum wa rahmatullahi wa barakatuh. I would like to welcome my students from grade 12 as part of our plan in Hadda Valley School to teach our students online so that they can stay safe at their homes and still continue studying. I give this recording of the first online lesson in mathematics. This is your teacher, Osama al-Mikhlafi, with you, and today we will resume with our last lesson, which we started with at school, which is permutations. So our lesson today will be about permutations. Just a reminder, this lesson is from Unit 2, and this is the second lesson. So you can find this lesson in this book, and this lesson is in Unit 2, and it starts at page 74. So this lesson is the lesson of permutations. Your homework today is going to be given from this exercise 2-2, page number 79, and we'll talk about that homework at the end of this video. Please feel free to pause this video whenever you like. If there is a point that you don't get very well, then you can always repeat it. You can repeat it forever. And if you have any problems, any questions, you can use our group in WhatsApp to ask me about any inquiries that you have. Okay, so if you still remember, in the previous lesson we started with the idea of factorial, and we elaborated on the meaning of the factorial and the properties of the factorial. But today we will start with the other part of this lesson, which is the part of permutations. Okay, so let's say that you have 5 different people, and what you need to do is you need to arrange these 5 different people, arrange them on a straight line to sit on 5 different chairs. Okay, so, and let's say that the question was how many arrangements can we have? Okay, so looking deeper into this question, we can say that these 5 people are A, B, C, D, and E. These are 5 different people. And what we want to do is we want to seat them. We want to seat them on a straight line on 5 chairs. So if we try to tackle this question from the idea of counting principle, we still remember that in counting principle we used to divide our processes into actions. So we can say that we have 5 different actions in this question. I mean with 5 different actions is seating each one. So this is your first chair, this is your second chair, this is your third chair, this is your fourth, and that's your fifth. If you want to arrange 5 people on chairs, then you're going to have 5 actions. You will choose someone to sit on the first chair, you choose someone else to sit on the second chair, the third chair, the fourth, and the fifth. So you have 5 different actions. And now let's see how many options do we have in each of the actions. So for the first one, you might notice that we can have 5 different choices. So here we actually have 5 different choices because you can choose the person A or B or C or D or E. So these are 5 choices. So when you come to the first chair, you have 5 options. One of the 5 people you have in front of you, you will take one of them and you will have him seated. Now you still have 4 people. So now you move to the second action, the second chair. In the second chair, you have only 4 choices now, because the 5th choice is someone who already sat on the first chair. So now you have 4 choices only. Here you have 3 choices only, since 2 people have already been sat down. And here you have 2 choices, and this is 1 choice only. Now the answer to this one is going to be 5 times 4 times 3 times 2 times 1. And I guess you might remember from our previous class that this is called 5 factorial. 5 factorial means the product of all the numbers starting from 5 and decreasing by 1 until you reach 1. So this is 5 factorial. And the answer, of course, to 5 factorial is 120. So there are 120 ways to do this process. Actually, we can express this answer in another way, not using the factorial, but using what we call the permutation sign. So the word permutations stand actually for arrangements. So permutations is only a synonym of arrangements. And in this question, we're actually arranging 5 people on 5 chairs. So this is a question of permutations. And you can express this answer in another way. You can say that this is the permutations of 5 people on 5 places. Again, this answer, which is 120, it is the permutation of 5 people in 5 places. The arrangements of 5 people in 5 places. And as you notice, this is going to be 120. So we generally say, if you can write this as a note in your copybook, note, please make sure that you write these notes in your copybook. Remember that your copybook is your ultimate reference for studying for the end of the year exam. You need to take good care of it. So if we need to arrange n elements in n places, n elements in n places. So you notice that the number of the elements is actually equal to the number of the places. You have 5 people, 5 chairs. You have 5 people and you want to arrange them in 5 chairs. So everyone is going to be seated. So if we need to arrange n elements in n places, then the number of possible ways, will be in permutation n. And you can notice that in permutation n is actually equal to n factorial. You see, 5 permutation 5 is the same as 5 factorial. You get the same answer, it's 120. So n permutation n is equal to n factorial, and this one should go into a little cloud of our clouds, because this is our first formula in this lesson. So this is our first formula in this lesson. In permutation, n is equal to n factorial. Good. Okay. What if this question was a little bit different? So what if we have 5 people, okay? We want to arrange them, but this time we don't want to arrange them on 5 chairs. We want to arrange them on 3 chairs. So we will actually 3 people only will sit and 2 will not. So we have 5 people and we want to arrange these 5 people, arrange them on 3 chairs, not 5, but 3. 3 chairs. So again, this time, not everyone will be seated. We'll actually select 3 from the 5, and then we will arrange these 3. So I can select A and B and C, and then I have different arrangements. Maybe A will sit first, and then B, and then C. Or maybe A will sit first, and then C, and then B. Or maybe B will sit first, and then A, and then C. Or maybe B will sit first, and then C, and then A. I hope you get the idea. Or maybe we will not choose A, B, and C. Maybe we'll choose B and C and D. Maybe we'll choose C and D and E. We will choose 3 out of the 5, and then we will arrange those 3. So the question is, how many ways can we do that? In how many ways? How many ways, or how many arrangements can we have? And maybe the number at the beginning will seem like it's infinity, but actually it's not infinity. It's quite an easy process to be calculated. So let's see. We can still tackle this problem with the counting principle. So we can still say that we basically have a process that is composed of 3 actions, because we will seat 3 people. We have 3 chairs. So we will choose someone for the first chair, that's our first action. Choose someone to sit on the next chair, that's our second action. And then choose someone to sit on the third chair, and that's our third action. Now, how many choices do we have in each? You might notice that in the first one, we have 5 choices, because I can either choose A or B or C or D or E. Now, someone will sit down here, so we have only 4 choices for the second place, and 3 choices for the third place, and then I have 2 more people who will not sit down. So in this case, our answer is 4. 5 times 4 times 3. This cannot be expressed as a factorial, because it did not reach all the way to 1. But it can actually be expressed in another way. We can express it as a permutation. How is that? We can write this as the permutation of 5 people sitting on 3 chairs. And this is going to be equal to 5 times 4 times 3, which is 20 times 3, which is 60. So you notice that we can always express such arrangements as a permutation. And now the question is, if we have something already like this, how do we calculate it's equal to 60? So if we know it is P53, how do we get this answer? Good, so let's move to the second page. So this is our first page. Okay, so let's see. Now, in the previous page, we have seen a relationship between permutation n and the factorial, right? But we have not seen a relationship between permutation n r and factorial. You see, we have seen a relationship between permutation n and the factorial, and we saw that they're equal to each other. But there is no relation yet between n r, I mean different numbers, not the same number. N is the same number. In r and a factorial, we don't have a relation yet. So let's see if we actually have a relationship. Yes, we actually do. Please write this in your copybooks. This is the relation between permutations and factorials. So this is the relation between permutations and factorial. Okay, look at this, guys. The first relation that we have established together was n permutation n. And we noticed together that this is equal to n factorial. So this is the first relation between permutations and factorials, and we give it this little cloud. Okay, what if these two numbers are not the same? So what if we have in permutation r? So they're different. It's like 5 and 3 in the previous example. So in this case, how do we evaluate this? Is there a relationship between this one and factorials? And the answer is actually yes. Yes. The relationship is going to be as follows. It's going to be n factorial over n minus r factorial. So this is the relationship between n permutation r and the factorial. Let's give this also a little cloud, and let's make sure of this. Let's check this formula. Let's check it. And how do we check it? We'll check it with the previous example. Remember, in the previous example, I had permutation 5, 3, and the answer turned out to be 60, right? Let's say that we don't know this answer, and we actually want to evaluate this permutation 5, 3, using this formula. Will we get 60? Let's see. Okay, so let's see. So, using the formula, we should get the following. Look at this, guys. So we have 5 permutation 3, right? So according to the formula, this should be 5 factorial over 5 minus 3 factorial. You see, it's n factorial, n is this number, n minus r, it means this minus this. 5 minus 3. Okay, so what is 5 factorial? 5 factorial is 5 factorial. We'll just open it in a sec. 5 minus 3 is 2, so this is 2 factorial. Good? Now let's evaluate each one of them. So 5 factorial is actually 5 times 4 times 3 times 2 times 1 over 2 factorial is 2 times 1. So now we can cancel. Let's cancel the 2 with the 2 and the 1 with the 1. So what do we get? We get 5 times 4 times 3, and 5 times 4 is 20, and 20 times 3 is 60. So we get the same answer we got there. So it's 60, which is good. Nice. So this here is the relationship between permutations and factorials. And actually we have two different relationships. It's either in permutation n, which is n factorial, or in permutation r, which is n factorial over n minus r factorial. We can use this actually in many examples. Look at this, guys. And please write this example in your copybook. So let's say that we have this example. You don't have to write everything I write on the paper in your copybooks, but I will always draw your attention whenever there is something that needs to be written in your copybook. So an example, say that we want this desire to compose, we want to compose a flag, okay? A flag like the Yemeni flag. So we want to compose a flag that is made of three stripes, like the Yemeni flag. 3 stripes with 3 different colors, Good. And let's say 3 different colors, and let's say that we have out of 5 available colors, or let's make it 6 available colors. So the question is, in how many ways can this be done? In how many ways can that be done? Can this be done? Good. So let's see. We can use the counting principle here, but this time I'm going to attempt to solve it using permutation right away. So how do we do that? So I basically have 6 colors, and I want to choose 3 colors out of these 6 colors, and I want to choose them and then arrange them. It's the same problem with the people and the chairs. So with the people and the chairs, we chose the people and then we arrange them on the chairs. So this time you're going to select 3 colors out of the 6 colors, and then you're going to arrange these colors. So it's a permutations problem. So this is basically going to be 6 colors in which we want to choose 3. So it's 6 permutations, 3. You have 6 colors, and you want to select 3 out of these 6 colors, and you want to arrange these 3. So the answer should be equal to 6 factorial over 6 minus 3 factorial, which is going to be 6 factorial over 6 minus 3 is 3 factorial, which is going to be 6 times 5 times 4 times 3 times 2 times 1 over 3 factorial is 3 times 2 times 1. We'll cross out the similar factors, 3, 2, and 1. So the answer would be 6 times 5 times 4. 6 times 5 is 30, and 30 times 4 is 120. So there are 120 different flags that we can make out of this problem. We will pause a little bit now, and then we will resume with some more examples briefly. Okay, so we are back now, and as we have seen in the first part of this video, we learned that the meaning of permutations is arrangements. We saw how do we evaluate the permutation of n people or n elements that are or n elements in n places, and we also saw how do we evaluate the permutation of n elements in r places. Now, and we saw the relationship between permutations and factorials, and we ended with an example of evaluating of solving a question using permutation. And we actually evaluated this permutation using this formula right here. But what we need to know, this is page number 2, what we need to know is that there is actually another way of evaluating a permutation that is way less complex than this one. This one is easy, I'm not saying that's difficult, but there is another way with which we can evaluate a permutation easier than this. So let's see. So let's discuss some questions. Let's solve some exercises. So here we have some exercises. And let's say that we want to evaluate, so that our exercise is to evaluate means find the value. So we want to evaluate each of the following permutations. Evaluate each of the following. Please write this in your copybook. 7 permutation 2. Okay, so to solve this one, we can use the second relation, which is the relation between the permutation of n elements, permutation nr, and the factorial. So we can say that the answer here, we can say that this is actually 7 permutation 2 is actually 7 factorial divided by 7 minus 2 factorial. Now 7 factorial is going to stay the same for now, and 7 minus 2 is 5 factorial. 7 factorial is 7 times 6 times 5 factorial. I mean times 5 times 4 times 3 times 2 times 1, but we can say that this part is actually 5 factorial. It's the same thing as the gun thing that we explained before in the class. You take 7 out, you get 6 factorial. You take 6 out, you get 5 factorial, so it's the same thing. And you divide that by 5 factorial, so now you're able to cancel both 5 factorial from both the numerator and the denominator, and the answer is going to be 7 times 6, which is 42. Good. So I think this is a bit easier than writing the whole thing again. Let's see another one. Sorry, for example, B. Let's say that we want to find the 20 permutation 3. So 20 permutation 3. So let's see. The answer is going to be as follows. So that's your answer. So 20 permutation 3 equals 20 factorial over 20 minus 3 factorial. The 20 stays as it is, so 20 factorial over 20 minus 3 is actually 17, so 17 factorial. Now we can say that 20 factorial is equal to 20 times 19 times 18 times 17 factorial divided by 17 factorial. And now we can cross out 17 factorial from both the numerator and the denominator. So we end up with 20 times 19 times 18, and the answer to that is going to be 6,840. You don't need to panic. You don't have such large numbers in the exam. Usually the numbers that you will have in your ministry exam, I'm sorry for that, the numbers that you will have in your ministry exam is something like this, like the first example. Okay. Some teachers and some mathematicians like to evaluate this answer in a different way. Like, for example, if you have, say you have 10 permutation 4. So you can actually evaluate this in a faster way than, so the answer here. You can use the counting principle to evaluate a permutation problem. And the way you do that, so you write 4 places because you have 4 actions. This is the number of the actions. It's 4 places, and then you write 10 here, 9, 8, 7. Whether you solve it this way, you get the same answer. So 10 times 9 times 8 times 7, that's going to be, the answer to that is going to be 50, 40. This reminds you of something, right? This number is the same as 7 factorial, yes. Okay, so good. So, so this is one way of evaluating permutations, and that's another way, and you can choose either. It's okay. So if you have a question like this, that's the final answer. If you have a question like this, that's the final answer. And you can expect a question like these in a multiple choice question. So let's move on to another point. Now sometimes your question will be backward. And what do I mean by that? Sometimes they can tell you to find the value of n. Please write this as well in your copybook. Find the value of n in each of the following. In each of the following. How is that, and what do we mean by that? Let's see. A, they give you something like this. So permutation, let's say 10, let's say n, and here 4 equals 50, 40. Now this question is a backward question. You see, this question is actually the same as this question. 50, 40 is the answer. The number of actions is 4 in both cases, and n is going to be 10 for sure. But here we just assume that we don't know this, if we don't know this line. So the question is, how do we figure out that the value of n is actually 10? So this is a backward question. They give you the answer and they ask from you to find the value of n. And the method that we follow to do this is a method that we have seen last year, and a method that we might be familiar with, which is the method of prime factoring. Okay, so 50, 40. Okay, in prime factoring, guys, in prime factoring, I cannot divide by whatever I like. No, we can only divide by a certain number of the numbers, by specific numbers, and these numbers are the prime numbers. And what are the prime numbers? The prime numbers are the numbers that only have 2 factors. The most important prime numbers that you need to know always are 2, 3, 5, and 7. Yes, the rest is long, and in some rare occasions you might need some of the other numbers, but as a beginning we need to know that our prime numbers, the most important ones are 2, 3, 5, 7. What follows 7 is 11. What follows 11 is 13. There is also 17. There is 19. There is 23. Okay, all of these numbers are prime numbers, but we really care most about 2 and 3 and 5 and 7. This is what we use most of the time. So, how do you know whether you choose 2 or 3 or 5 or 7? Well, choosing 2 is quite easy. If the number is even, so it ends with a 0 or a 2 or a 4 or a 6 or an 8, this digit, then you choose 2. You divide by 2. So I'm going to divide by 2. Okay, so let's divide by 2. And I'm going to use a pencil for this. So let's see. So if we divide by 2, we'll start from here. So we will ask ourselves, this is 5. Can we divide 5 by 2? Is 5 one of the numbers that we can find in the timetable of 2? And the answer is not. No, 5 is not in the timetable of 2. So let's reduce 5. Let's minus 1 from it. If you minus 1 from it, how much do you get? You get 4. And 4 is in the timetable of 2. So reducing 5 into 4 is a good idea because 4 is in the timetable of 2. Okay, so you reduced how much exactly? You reduced 1. Where do you put that 1? You put it here. So this does not. So this becomes 10 and not 0 anymore. And now you can divide 4 divided by 2, and the answer is 2. 10 divided by 2, the answer is 5. 4 divided by 2, the answer is 2. 0 divided by 2, the answer is 0. Good. So we divided by 2. Now, you notice that this here at the beginning is a 0. It's an even number. So can we divide this by 2? Yes, we can. So let's divide it by 2. So here we go, 2. Okay. So 2 divided by 2 is 1. This is good. 5 divided by 2 cannot be done. So the same thing that we did before, we'll reduce it to 4. Reduce it by 1. So we put the 1 next to the 2. It becomes 12. So 4 divided by 2 now is 2. 12 divided by 2 is 6. And then 0 divided by 2 is 0. Good. So we have 1260. Let's continue. It's an even number. I can still divide it by 2. As long as you can divide by 2, go ahead, divide it by 2. So now 1 divided by 2 cannot be done. So we reduce the 1. It becomes 0. And the 1 actually comes here. So 0 divided by 2 is 0. 12 divided by 2 is 6. 6 divided by 2 is 3. And 0 divided by 2 is 0. Okay. It's an even number. We still can divide by 2. Look, this 0 on the leftmost is not really important. You can divide it, but you just can leave it. Just start from the 6. So 6 divided by 2 is 3. 3 divided by 2 cannot be done. So we need to reduce that 3. So it becomes 2. And this is 10. So 2 divided by 2 is 1. And 10 divided by 2 is 5. And now we end up with 5. 5 is an odd number. It's not an even number. So we cannot divide by 2 anymore. So now we can't divide by 2. So what do we need to do? We need to check if it's divisible by 3 or not. And how do you check if it's divisible by 3? The method that you use to check if it's divisible by 3 is the following. You add these digits together. So if you add them, what is 3 plus 1 plus 5? The answer is 9. Okay. If the sum is 9. If the sum is something that you can divide by 3, then the whole thing can be divisible by 3. Again, if the sum is something that you can divide by 3, then the whole number can be divided by 3. If the sum is something that you cannot divide by 3, then the number cannot be divided by 3. Just always know that. So in this case, let's erase this. So in this case, we can actually divide by 3. So I'm going to choose 3. So let's choose 3. So 3 here. Let's divide now. 3 divided by 3 is 1. 1 divided by 3 is not possible, so we reduce it Don't pass that. Now you need to reduce it. It becomes 0, and this becomes 15. So 0 divided by 3 is 0. You have to write this number. This number is important. 15 divided by 3 is 5. Okay. Now let's check if this is divisible by 3. And the way we do this, we add the digits. So 1 plus 0 plus 5, the answer is 6. And 6 is divisible by 3. So we can divide this number by 3. So let's do it. So divide by 3. So let's divide it by 3. Okay. 1 divided by 3, that's not possible. So you reduce it, becomes 0, and this becomes 10. So 0 divided by 3 is 0. Now, 10 divided by 3 is not possible. So we reduce it, it becomes 9, and this becomes 15. 9 is good, so 9 divided by 3 is 3. 15 divided by 3 is 5. That's 35. Now, let's check if it's divisible by 3. Add them together, you get 8. If the sum is not divisible by 3, then the whole number is not divisible by 3. So this means that we cannot choose 3 anymore. So now we move to what? To 5. Now, so 5. It's actually divisible by 5. How do we know if it's divisible by 5? If it ends with a 5 or a 0. So this one ends with a 5. So it's divisible by 5. So let's divide by 5. 0 divided by 5. It's not important to start from the leftmost if it's 0. Let's start from the 3. 3 divided by 5 cannot be done. So we reduce it, becomes 2. We reduce it, it cannot be done. We reduce it, it becomes 1. It cannot be done. We reduce it, it becomes 0. So we keep reducing it until it becomes 0. So how many numbers did we reduce? We reduced 3 numbers. We put them here. So 0 divided by 5 is 0. And 35 divided by 5 is 7. Well, it's quite basic now. We cannot divide by 5, we can divide by 7. So let's divide by 7, we will get 1. So getting 1 means that we're done with our prime factoring. But the question is, how do we get this 10? Okay, remember this is our question. So how do we get this 10? Let's see. You select the largest odd number in the sequence. What is the largest odd number in your sequence? It's going to be 7. And I prefer that you start with a pencil here. So you write 7 here. Okay? So this is your largest odd number, 7. Okay? Now you ask yourself, can I get something that is before the 7 or after the 7 out of these numbers? So you need either a 6 or an 8. So actually you can get a 6. Okay, let's show you how is it when you go in the wrong direction. Okay, you can get a 6, so you do a 6. Okay, so what do you need to follow the 6? You need a 5 to follow it. You actually have a 5. Okay guys, this is 6 because 2 times 3 is 6. 2 times 3 is 6, that's why I wrote 6. Then 5, that's a 5. Okay, I need a 4. I can get 4 by multiplying 2 by 2. Multiply, not add, multiply. So multiply 2 by 2, you get 4. Then, can I get 3? Yes, I can get 3. Okay, I'm doing good. I'm going in a sequence. Can you get 2? Yes, you can get 2. I'm doing this with a pencil. Don't do it with a pen. I'm doing it with a pencil. So I got this sequence. But I have a problem. What's exactly my problem? I needed only 4 actions. I have 1, 2, 3, 4, 5, 6 actions now. So this cannot work. I need it to be only 4 actions. So maybe this direction I went with is not correct. So let's try something else. And guys, you need to know that these questions have a factor of trial and error. You need to try, and you might make a mistake at the beginning, but you keep trying until you get the right answer. So we have established that this sequence is actually not good. So let's try another sequence. And let's do the same thing. You'll always have to start from the largest odd number, so that's 7. But this time, instead of going into lower numbers, let's try to go into higher numbers. So I need an 8. If you multiply 2 by 2, you get 4. and then you multiply 4 by 2, you get 8. So multiply 2 by 2 by 2. 2 by 2 is 4, by 2 is 8. So this is an 8. And please make a sign here so that you don't choose it again or you don't leave it behind. You need to make sure that you chose all the numbers and you chose them only once. So that's 8. What about 9? Okay, 7. I'm sorry, 7. Of course, we chose 7 first. What about 9? Okay, 9 can be evaluated from these two numbers. So 3 times 3 is 9. So good. Okay, what about 10? Yes, we have a 10. The 10 is actually these two together. These two together is a 10. That's a 10. Okay. So this is more like it. We have only 4 actions for 50/40. So what we can do now is we say the following. So n permutation 4 equals 50/40 is actually can be written like this. 10 times 9 times 8 times 7. These are consecutive numbers. They follow each other. They reduce by 1 every time. So we can say that this is 10 permutation and there are 4 actions. So this is 4 actions. You write the largest number on the top and the number of the actions in the bottom. So this is n permutation 4 equaling 10 permutation 4. And what does that mean? It means that since it's the permutation in both sides and it's 4 in both sides, so for sure n is how much? N is 10. So therefore n is equal to 10. So we got this 10 back. And this is one example of a backward question. Okay. Please make sure that you wrote everything that you have here on this page in your copybook. And now we can move on with another question. If you need to have a break, you can always pause the video for a while, get the break that you desire, and then come back. I will always be there in the video. Okay, let's see. Okay, let's just make this right. So we are still doing exercises, and we're doing backward exercises, backward questions. So exercises. All right, so let's see some other questions. And I am going to select some of the questions from the book. These questions I'm selecting are from exercise 2-2. This exercise is on page 81. No, I'm sorry, it's on page 79. But the question that we're going to be solving right now is this question. So it says find the value of n. So we expect it to be a backward question. So find the value of n. Find the value of n in the following, in each of the following, in each of the following. And let's see this question together. So the question says, of course, this guys is question 3 in the book, and I am solving part E. So part E says that we have n permutation 4 equals 14 multiplied by n minus 2 permutation 3. Okay, so let's see how do we solve this question. So in this question we are required to find the value of n, and this question or this type of questions is easy to be formed in a multiple choice way, as a multiple choice. So I can give you this in a multiple choice question and then tell you that the value of n, and then I give you some choices. So you expect some questions like these in your end of the year exam. And how do we solve this one? It's honestly quite easy. Let's see how. So look at this. The most important thing that you need to bear in mind when solving a question like this is the sequence of n that we talked about before. So it's n. When you get the next number in line, you get n minus 1. The next number in line is n minus 2. The next number in line is n minus 3. And you keep reducing 1 every time, so you get a sequence. It's like when we have an 8, and then you minus 1, you get a 7, and then you minus 1, you get a 6, and then you minus 1, you get a 5, and so on. N minus 2, you minus 1, you get n minus 3, you minus 1, you get n minus 4, you get and so on, okay? So this is a sequence of n that you need to know here. Why? Simply because in this side, this is not a proving question, so I can use both sides, okay? It's not a proving question. When they ask us to prove something, we take either the left-hand side or the right-hand side, but this is finding a value, so we can use both sides actually, okay? So what I am going to do is I am going to evaluate this permutation. And how is that? I have 4 actions, and these 4 actions start with n. So we have 4 actions, and these 4 actions start with n. So the largest number in the sequence is n. Okay, then what happens? Then you reduce 1. Like you start with 8, and then you reduce 1, you get 7. It's the same thing here. So you reduce 1, you get n minus 1. And then you reduce 1, you get n minus 2. And then you reduce 1, you get n minus 3. These are 4 actions that start with n. Equals 14 times. This here is not 4 actions, however. It is 3 actions only. And these 3 actions start with n minus 2. So it starts from here. So it's n minus 2. Please make sure that you put this in brackets because it's 2 terms, not only 1 term. And then you minus 1, you get n minus 3. And then you minus 1, you get n minus 4. So these are 3 actions that start with n minus 2. Okay, good. Now what do we do? Okay, look at this, guys. You see here these two, n minus 2 and n minus 3, are actually the same in both sides. So you can divide both sides by n minus 2, n minus 3, or you can just cancel them from both sides. Okay? So what do you have now? So you have n multiplied by n minus 1 equals 14 multiplied by n minus 4. Okay. What can we do now? We can simply open the brackets. So we multiply n into n and n into 1. We multiply 14 into n and 14 into negative 4. Let's do that. N times n is n squared minus n times 1 is n equals, on the other side we have 14 times n is 14n minus 14 times 4. Well, this is going to be 56. This is good so far. Okay, now this is an equation, but this equation is quadratic, and to solve a quadratic equation we need to make it equal to 0. So we need to move these terms into the other side. So this becomes n squared minus n, then minus 14n, which was transposed from the other side, minus 14n plus 56 is equal to 0. And I apologize for this. So n squared minus 15n, since you have minus n and minus 14n, you add them together because they're both negative, plus 56 is equal to 0. And now you factorize it. So 2 brackets equal to 0. You ask yourself, this n squared is n times n. The signs, you take this minus down. So this is minus. And in the other bracket, you need to multiply the 2 signs by each other to see what is the sign of the other bracket. So you multiply minus by a plus, you get a minus. You put that minus in the other bracket. And now you ask yourself, I need 2 numbers. If I multiply them, I get 56. And if I add them, I get 15. Well, these are quite straightforward numbers. They're 8 times 7. 8 times 7 is 56. If you add 8 with 7, if you add them, you will get 15. So you put 8 first and then 7. So either n is equal to 8 or n is equal to 7. And this concludes our answer. Okay, let's investigate another question. Let's see another question. And again, I encourage you to take breaks whenever you need one. Whenever you need a break, just take it. Pause the video and then come back to the place where you left us and continue. So let's do another one. I am going to do question F in the same page. So in this question, we have 7 times n permutation 5 equals to n permutation 3 times 9 permutation 3. And let's see, they're asking us for the same thing. So they want us to find the value of n. Let's do this quickly. So let's start. So we have 7 here times. We have 5 actions that are starting with n. So 5 actions starting with n. So n minus 1, n minus 2, n minus 3, and n minus 4. These are 5 actions equals to n permutation 3. 3 actions starting with n. So n minus 1, n minus 2 times 9 permutation 3. So this is 3 actions topping with 9. So 9 times 8 times 7. Okay. We have made ourselves a mess right now, but we can simply clean this mess out. How do we do that? Easy. Take n out from both sides. Bye-bye, Mr. n. Take n minus 1 out. Take n minus 2 out. Take the 7 out. Bye-bye, 7. So what do we get now? We get n minus 3 multiplied by n minus 4 equals 9 times 8. Okay? Now from here, there are actually 2 ways to solve this one. There is what I call the smart way, which I encourage you to do to find the value of n. And there is of course the donkey's work. Yes, exactly. Donkey's work. Donkeys are not stupid, by the way. Donkeys are smart, but they just love to work hard. Sometimes we don't like to work hard. We just like shortcuts. So let's see the donkey's work first, because we love donkeys. So let's see what to do. We're going to open the brackets. So n times n, that's n squared. And n times negative 4, we're foiling them up. So minus 4n. And then negative 3 times n is minus 3n. And then minus 3 times minus 4 is positive 12. We'll take a small break now, and I'm going to come to you just in a second. Sorry, I had to go into a little break. Okay, now, so we were opening these two brackets by foiling, so we foiled them. We got this expression equals to, in the other side, 9 times 8, which is 72. Now, this is a quadratic equation, so we need to take this to the other side. So we have n squared minus 4n and minus 3n is actually minus 7n. They're both negative, we add them. Plus 12 minus 72 equals to 0. These two are both numbers, so we can just add them or subtract them, whatever suits us. So n squared minus 7n. Here we're going to subtract them since they have different signs. So we have minus 60 is equal to 0. So now what are we looking for is two numbers. If you multiply them 60, if you minus them 5. This can be challenging at first, but actually the numbers are quite easy. So it's n and n, okay? The signs are minus right here. Minus times minus is plus. Now, two numbers, if you multiply 60, if you minus them 7. Not the same as here. Here we said if we add them 15 because it's plus. Here, if you minus them, it's 7. So these numbers are actually, I hope you guessed it right, it's 12 times 5. 12 times 5 is 60. You minus them, you get 7. So you write the bigger number first and the smaller number second, 12 and 5. So either n is equal to 12 or n is equal to negative 5. And actually the second answer is rejected. And the way we reject it, and the reason we reject it, is because it's negative. N cannot be negative. It cannot be negative, it cannot be 0, it cannot be decimal or fractional. It needs to be a whole integer, a whole positive integer. So the only possible answer that we have here is n equals 12. Okay, so this is a good way. It's donkey's way, but it's a good way. It's donkey's work. And what about the other way? So what is the other way? The other way is not feasible all the time. You cannot just do it all the time. But you can do it sometimes when, let's see, when you have two numbers that are after each other. These are actually after each other in the sequence. It's n minus 3, n minus 4. So they're consecutive numbers. 9 and 8 are the same thing. They're consecutive numbers. We can do this. We can rewrite this as a permutation. So it's how many actions do you have here? You have two actions. And what is the largest of the two actions? It's, of course, n minus 3. n minus 3 is larger than n minus 4. It's changing a number into a permutation. And after the equal sign, you have the same thing. So you have two numbers. So it's a permutation of two actions. And what's the larger number? It is 9. Now you see two permutations that are equal. And they have the same r. So they must have the same n. So this means that n minus 3 is equal to 9. Transpose this to the other side. So n is equal to 9 plus 3, and the answer is 12. So we got the answer, I think, in an easier way. And we only got the accepted answer. We did not get the rejected answer. So this, I think, is a smarter way. Either ways, the ministry is not going to look for your ways. You have multiple choice questions, so what they care about is the final answer. And what you need to care about is how do you get the final answer correctly. If you get the final answer correctly, you're in the safe side. If you can't get the final answer correctly, nobody cares about the steps, unfortunately, this year. So please make sure that you can follow, you can do each step by yourself, independently. We'll stop here today. And before I leave you, I am going to give you some questions as homework, and inshallah next class we will pick up from where we stopped. I hope that you're safe at home, you're not doing anything dangerous, Remember, your health and the health of your beloved ones is the most important thing. And please keep studying, because if you don't study, you'll forget everything. This is my personal advice to you. Your homework is going to be on page 79. I hope you can see this. It's question 3D. You can write this down. Question 3, D. Okay. And question 1, sorry. Question 1, A and B, and C and D. If you can do all of them, it's actually an easy question. So question 1, all of it. From question 2, I would love if you can solve B and E. B and E, and give F a try. We will discuss it in the next class, but give it a try. B and E. So again, question 1, all of it. Question 2, B, E, and give F a try. Question 3, I need you to solve question or part D. That's all for today. I hope that you're going to have a great day, and thank you for listening.